All right, ladies and gentlemen, there's not much context to this problem. This is our one sample t interval for matched pairs or paired data, you can also say. But it's apparent here that we have 11 subjects, and they, anytime we have an experiment, we're going to assume that they're volunteers, because in the real world experiments, people do volunteer to be part of the experiment. Is caffeine dependence real? So the table below shows the data on the subject scores on a depression test. Higher scores show more symptoms of depression. So they're wondering if there's a true mean difference in depression scores from after having caffeine, okay, after having caffeine. So let's get going. We're going to construct a 95% confidence interval for the true mean difference in depression scores. All right, ladies and gentlemen, the first thing that we want to do for state is we want the parameter. With an interval, we do not need a null hypothesis, an alternative hypothesis, and we do not need an alpha level, okay? We're going to just go ahead and get right to the state. Our mu is equal to the true mean difference in depression scores. We jump right to the plan now. Again, the new learning from last time was, hey, we have this prin now instead of this rin. The plan is we have we have paired data. How do I know I have paired data? Well, because each subject clearly had a placebo as well as caffeine, the way this is, and you can just take my word for it as well. But again, when you see it looking like this is saying, hey, this subject had caffeine and took a depression test, and then this subject also had a placebo pill and took a depression test, okay? Same thing here, 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 and here, okay? Higher scores show more symptoms of depression. R, randomization. This is an experiment. Experiments have volunteers, so that it wasn't like they were their names were randomly pulled out of a hat. But what we can assume right now, if this had more context to the problem, we're going to assume the caffeine and placebo were randomly given. So you don't know what you had first. I'm guessing it was probably a double-blind experiment where this, just as a quick review, the subject didn't know and the statistician or the person in charge of the experiment didn't know, but the statistician or the person who's running the experiment from above, that person knows who gets who, okay? Who gets what, excuse me. So we're going to assume that the order in which you got caffeine versus placebo, let's put the order. Was randomly given, okay? Next, what we learned from the last, give me a second here. What we learned from the last one, or the last video, is that for paired data or a matched pairs experiment, for the independence rule, what we just say is we say subjects' responses were independent of each other. Okay. Again, that was new learning from the last video. Then the normal condition. This is the same thing based off the central limit theorem because we're dealing with means. We need n to be greater than or equal to 30. Well, we have 11. 11 is not greater than or equal to 30. So when that happens, you guys, we need to go ahead and we need to graph the differences and make sure that it is the probability plot, which was new learning from last time, is somewhat straight and that there are no outliers. Let's do that now. So what I want to do in my calculator, ladies and gentlemen, I want to put L1, the caffeine, L2, the placebo. Let's pause it and then we'll join together and I'll show you how to type in L3 and how I would type it in, okay? Okay, ladies and gentlemen, now what I want to do is I'm interested in the difference between the placebo and the caffeine. And I like to work with positive values when we're dealing with differences. So I'm going to briefly just look and see which one has bigger values. In general, it looks like with the placebo, the depression tests were higher in general, not for every individual, but in general. So what I'm going to do is I'm going to set it up as L2, so second 2 minus second 1. That's going to give me mostly positive values, all with the exception of 1 there, you can see. So here are our differences in the placebo, or in the depression test with the placebo and the caffeine for each individual subject. Now I want to investigate I want to figure out what the true mean difference is for people like the ones in the study, okay? So I'm going to generate a lower bound and I'm going to generate an upper bound to see what that true mean difference in depression score would be with caffeine versus a placebo. How am I going to do that right now? Well, first, let's go back to why we entered it into L3 in the first place. We need to make sure, though, that this condition right here, guys, this condition was not met The T distribution's robust. Let's go ahead. Let's go first, look at the box plot. Let's make sure that there are no outliers in our L3. Hit enter, zoom 9. I have no outliers, and in fact, this looks pretty symmetric. It's symmetric enough for me. Hopefully it is for you as well. So what I'm gonna do is I have my graph right here, and I'm gonna state box plot is mostly symmetric with no outliers. We're okay to proceed. Let's write down what that method is, okay? What that method is. And I talked about the importance of that one sample in the last video versus two samples. We have one sample where two things are happening to that one sample. It's a matched pairs experiment. I have one sample, T interval. You can say for matched pairs or for paired data is kind of what the newer textbooks are saying. We used to say for matched pairs, so I'm so used to saying matched pairs. You won't get docked on a test for that for paired data. All right, we're done with the plan. We're going to go ahead and we're going to do the do. We're going to fill in what we need here. So this X bar of D means the X bar of the differences, the average of the differences. Let's go ahead and let's actually just go to the calculator and compute the T interval, which will help us to fill some things in. We will have to go to our table as well to find that T star. So I'm going to go to my calculator right now. I'm going to go to stat. I'm going to arrow over to tests, and I'm going to go to the T interval. That's number 8. I am dealing with data, not statistics. Statistics would be if they told me what the X bar of the difference was and what the standard deviation of the difference is. They did not tell us that. Where our data is an L3, our frequency will stay at 1, and we want a 95% confidence interval. So we're going to go ahead and we're going to calculate. I'm going to pull this over so it's easier to talk about. Okay, I know we have our lower bound and our upper bound right here, but you guys do have to fill this formula in to get full credit. I have my statistic. I'm going to go to the board actually and do that right now. Okay, so I have my statistic. My statistic is 6.4545. Plus or minus my T star. I'm going to leave that blank right now. We'll go and look at that in a second. My SX, this is my standard error right here, ladies and gentlemen. My SX is my standard deviation for that sample. That is right here. They give it to us. So 8.5833 divided by the square root of 11. And now my degrees of freedom are n minus 1. So my degrees of freedom are 11 minus 1, which is 10. And now I need to go and find that T star. So we need to go to our formula sheet right now. Give me a second, I'll pull them. Okay, so I have my formula sheet pulled up. And I'm going to go down and I'm going to go to table B. Remember, just a friendly reminder, when we're dealing with a confidence interval, when we're constructing it, here is our levels. This infinity row, this is our Z stars. And then all of these are T stars. We have a degrees of freedom of 10. So our T star is going to be one of these values. We're going to go down to 95%. We scroll up. Our T star then is 2.228. Again, our degrees of freedom is 10. Here's our degrees of freedom over here. Here is our row. Our T star will be one of these values. We go to our confidence level at 95%. We scroll up, we get 2.28. We have our interval 0.68822 to 12.221. And now we can go ahead, ladies and gentlemen, and we can conclude. We can do our I am 95% confident. I am 95% confident that the interval, oh dear, I have something a little different from last time. I hope I typed everything in right. If I didn't, well, keep the comments nice, I hope. 0.6822. I thought I double checked, to 12.211 contains the true mean difference in depression scores for the placebo minus the caffeine, okay? Now, ladies and gentlemen, a couple things here. One is make sure that you understand how to interpret a confidence level. We have interpreted the interval here. Go back in your notes, make sure you have that down. Interpreting an interval. Next, be ready for a follow-up question. What do I mean by that? A follow-up question could be, so based on the interval is there evidence that there is a difference? Okay, is there evidence that there is a difference? And then what you can do is you can say, well, yes, there is evidence that there's a difference. Why? Because if there was no difference, 0 would be in this interval somewhere, but 0 is not contained in my 95% confidence interval. And so, yeah, we do have evidence that there is a difference in those true mean, or in the depression scores. Excuse me for stumbling over my words. Next, the last thing I want to talk about is just sometimes you do need to calculate this statistic plus or minus your margin of error by hand. And you need to do that when, let's say your degrees of freedom was 45. You would have to round to 40 to find that T star. So whenever you round for degrees of freedom, okay, whenever you round for degrees of freedom, you do need to calculate your upper bound and your lower bound by hand, okay? Because it won't match up with what the calculator spits out because they they find the exact T star that you need. Let me know if you have questions on that in class later. Other than that, you should feel comfortable now with a 1 sample T interval for paired data, and I'll take questions and clarify in class. Have a great day, you guys.